Welcome to the Ready Academy. Tools for teaching, tools for learning, tools for life. In this video book, we cover trigonometry. This content was produced with AI assistance and reviewed by a human instructor. We'll continue with inverse trigonometric functions. Sine takes an angle and returns a ratio. The inverse problem is just as useful. Given a ratio, recover the angle. A surveyor measures opposite over adjacent, a navigator measures north over east, and an architect measures rise over run. Each of them needs to compute an angle from a ratio. The inverse trigonometric functions do exactly this job once you handle one subtle complication. Why inverses need restricted domains? A function has an inverse only if it is one-to-one, meaning no two inputs ever produce the same output. Sine, cosine, and tangent fail this test badly because they repeat the same values over and over. The equation sin x equals 1/2 has infinitely many solutions. Among them are pi over 6, 5 pi over 6, and each of these shifted by a full turn of 2 pi. To build an inverse, we first restrict sine to an interval on which it is 1-to-1. Animation 12. The full sine curve is crossed by the horizontal line, y equals 0.5 at infinitely many points, and every crossing is another angle with the same sign. Restricted to the interval from -pi over 2 to pi over 2, the curve meets that line exactly once, so only this stretch passes the horizontal line test. Figure 27. The sine function on its restricted domain from -pi over 2 to pi over 2. On this branch, the curve increases steadily from -1 to 1, so each output traces back to exactly one input. The conventional restrictions are called the principal branches. There are 3 principal branches. First, arcsine accepts inputs from -1 to 1 and returns angles between -pi over 2 and pi over 2. Second, arccosine accepts the same inputs but returns angles between 0 and pi. And finally, arctangent accepts any real number at all and returns angles strictly between -pi over 2 and pi over 2. A notational warning: sine to the -1 of x does not mean 1 divided by the sine of x. That superscript -1 marks an inverse, not an exponent. To avoid the confusion, this video book writes arcsine, arccosine, and arctangent. Figure 28. The 3 inverse functions side by side, arcsine, arccosine, and arctangent, each on its principal branch. Arctangent approaches the lines at plus and minus pi over 2, but never reaches them, because the tangent it inverts grows without bound. Using inverse trigonometric functions. Think of each inverse function as a machine that answers one question: what angle has this ratio? The catch is that the machine always returns the single angle from its principal branch. Finding every angle with that ratio takes one more step: reference angles and quadrant sines. Worked example: the angle of a ramp. A ramp rises 1.2 meters over a horizontal distance of 8 meters. Find its angle of inclination. The rise is opposite the angle and the run is adjacent, so use the tangent ratio. The tangent of theta equals 1.2 divided by 8, which is 0.15. Apply the arctangent to both sides to release the angle. Theta equals the arctangent of 0.15, which is about 0.1489 radians. Since arctangent always returns an angle between -pi over 2 and pi over 2, there is no quadrant ambiguity here. So theta is about 0.1489 radians, or about 8.53 degrees. Worked example: finding every solution. Find all values of x in the interval from 0 up to 2 pi that satisfy the equation. sine x equals negative 0.4. Ask the calculator for the arcsine of negative 0.4. The arcsine of negative 0.4 is about negative 0.4115 radians. This principal branch answer lies outside the requested interval, so use it only to find the reference angle. The reference angle is the arcsine of 0.4, about 0.4115 radians. Sine is negative in the third and fourth quadrants, so expect two solutions. In the third quadrant, add the reference angle to pi. X equals pi plus 0.4115, which is about 3.553. In the fourth quadrant, subtract the reference angle from 2 pi. X equals 2 pi minus 0.4115, which is about 5.872. The two solutions are x is about 3.553 and x is about 5.872. Try it. A surveyor stands 50 meters from the base of a building and sights the angle of elevation to its top. The top of the building is 73 meters above the surveyor's eye level. Find the angle of elevation, accurate to the nearest tenth of a degree. Pause the video now and work it through. The next one needs every solution, not just the principal branch answer. Try it. Find all x in the interval from 0 up to 2 pi that satisfy the equation. 2 cosine x minus 1 equals 0. There are two. Pause the video now and give it a try. The lesson worth remembering: the inverse function gives you exactly one answer. Finding all of them always calls for the reference angle reasoning you already know. That wraps up inverse trigonometric functions. Next up, Section 8, Solving any triangle. If you found this helpful, like and subscribe and support the channel.